How does a soft, fluid cell physically swallow a solid, rigid object? It's a process called phagocytosis. Immune cells can't just absorb complex bacteria. They have to deploy a mechanical trap. Take a single macrophage encountering an E. coli bacterium inside a tissue wound. The cell's outer receptors detect markers on the bacteria and sound an internal alarm. But there is a major mechanical problem. The cell's membrane is naturally flat and tense, and it's backed by a rigid internal skeleton that prevents it from bending around the invader. So the cell violently dissolves its own skeleton right at the point of contact. It rapidly rebuilds those raw materials outward, aggressively pushing the membrane into temporary fake arms. These extensions, called pseudopodia, reach out to completely hug the bacteria. The arms fuse together at the peak and pinch off. This traps the pathogen in a sealed internal bubble, which is called a phagosome. This bubble then fuses with an enzyme-filled pod to create a phagolysosome. It unleashes a highly acidic burst that actively dissolves the trapped target. So what happens to that invading E. coli from the beginning of our story? It is completely ripped apart into harmless proteins, effectively ending the bacterial infection right then and there.